I'm sorry. Yeah, I really wanted to use the left, but the left isn't working. Let me get that. Maybe I can. Yeah, so YouTube, everything is broken. Yeah, I don't feel good, really, and I struggle with my cluster. All in shambles. Yeah, I can go shopping. I need a better solution for all this crap here. That's so weird. Okay, how do I need to attach the output. Because oh yeah, char integration here. Chat is what? Yeah, you need the streaming elements. Streaming elements too. I don't know how to, if I can use that device somehow. I would love to have something more directional here, because I have so many fan noises. That's really bad. Hey Yumbo. So since last stream, what was the slightly noisy? Yeah, the oscilloscope is loud. Let me turn that off. The cluster is loud, and I put a power bank in between the cluster and my power line, because last time it tripped a breaker and it tripped the breaker again recently, so I had like to put a buffer in between, but it has some more fans. I don't know why it needs the fans, because it's not pulling a lot of power right now. So since what have we done last time? Oh yeah, I had an issue with DMA. Yeah, more than, yeah, I'm waiting for my shill money. Once I receive that, it takes always months to receive my money for my paid product placement or whatever. Once I receive that, I will invest. I would really need also a new camera, but that has to wait. I really want to get a new microphone. I don't know which one. Some lav that is smaller, easier to use, and it's not a Rode. Do I have a shotgun? You know what? Maybe I can use the shotgun capsule if I can't use the lav here, which seems to be problematic. Do I have an input on that microphone? No, but I have. Yeah, it's always like that. Oh well. Where is the shotgun piece? didn't use that for a long time. Oh, there's the shotgun mic. Okay, peeps, let's try again. The shotgun. I will mute. Okay, how is that? More or less noise? Hello. Oh, it's very contained in that space, so slightly less noise or slightly less audio. It looks like it's minus 12 dB. You can barely hear me. I can make it louder. Half a percent, but it's more annoying now because it is. Is it loud enough? Should I make it louder? It looks like it could be slightly louder. Okay, let me. Okay, let me do that. Loud enough? Okay, now we have minus, more or less minus 12. That's all right. Minus 10, minus 12. For dialogue, it's the perfect audio. All right, at least we improved that. So I had a long journey since last time. I tried to fix up things. So I was trying to code faster level 3. We noticed that our programming pins are connected to both MCUs, level 3 MCUs simultaneously, which is not great. Apparently we can program, but I noticed afterwards that it causes a lot of issues during debugging. As you can see, if you can, hey Fu! Oh, I thought about you. How are you doing? Is your family okay? Did you have you been impacted by the earthquake? Abby, hi. Oh, you're in a very good construction city. All right. Oh, that's good to hear. Yeah, I just. We noticed that in the middle of next street. What? Okay, so yeah, we noticed last stream that the programming pins are connected, which is bad if you try to debug. Apparently some like memory reads or whatever, you get random stuff. And then I struggled, I don't know if it was still during the stream and the day after, I struggled to get the DMA transfer initialized at all because I didn't receive the chip select signal. That was a little bit weird. Of course, scoping helps. I wasn't able to see the signal, the chip select. I don't know how the transfer worked before. It was apparently quite random. But it turns out I had a cold solder joints on the side of the chip with the pins for the chip select. So none of the chip selects actually had a connection. So I had to solder that, and I fixed that with my like bad eyes. I really need I really need something that's not so chunky and bulky like my microscope, because I can't move it to the table. Like I can't move the huge device underneath my microscope, and I can't move over the microscope again if I have to rework stuff. So that's one thing that you could, maybe I can try to get an advice from you. What kind of am I looking for, like microscope glasses or something like that? There are like, can't you just buy some sort of like glasses, not glasses, like magnifier glasses or something? I need that to be able to solder now chips like that. Microscope arms, yeah, I could use the microscope arm, but I really don't want to move the whole device, and I don't want to mount the arm on this presentation table. That's the issue. I would really just for the little reworks or solder jobs, fixing things, would really love glasses like that. But that's on our to-do list. Maybe I would write notes. To-do list. Let's look for those nerdy microscope glasses from the movies. Clock repair glasses. That's Uhrmacher. We can look that up. But before we start with that, yeah. So I fixed the chip select, and I was able to get nice and clean DMA transfers to level 3. But then what happens? Jeweler's glasses, yeah. So what happened then, maybe I can share the code. Can I share the code? Yeah, let me share some code. I had issues with, let me show. Okay, I removed also the object files. Apparently I had from the repository I had an ignore file, but I copied the project and called them level 0 min, and the min version wasn't in the git ignore, so I added that and removed the files from the repo, so we don't have that. But I added new stuff, which is, where's my library code here. So I prematurely optimized, because I thought, okay, we have SPI client. I implemented everything based on interrupts. So basically the interrupt handler was I even had this is the manual break. So the interrupt handler basically swaps the buffers and adds the buffer to a receive. Where is it? Here. SPI client RX buffers. It basically, whenever it received a buffer, it adds to a list. And since level 3, level 2 are basically routing nodes, they don't need to change anything about the buffer, and we can directly pass it down to the next SPI that even uses the same memory, saving a lot of time copying the buffers around. So that was the idea. I implemented DMA buffer, which is basically just another list. You have like let's say as a heap of buffers, and where is it? Is that? Nee, yeah. DMA buffer, yeah, DMA buffers. Foo, thank you very much. You really should donate money to the people of your country to help with the people who suffering from the terrible earthquake. But thank you anyways. You already done that. Oh, that's nice. Super. All right, so I did that. So basically what's happening here, we have like, I made a thread save since we are handling juggling the buffers between interrupts and non-interrupts. We have always like the critical section and are only changing lists while interrupts are turned off. So I had some issues with that. I fixed that. Then also what I implemented there is like it was working both ways. So SPI full duplex at the same time with DMA. And the issue that I encountered afterwards, I thought, yeah, I make it nice and clean, and everything is nice and dandy, and I thought now we can basically finish our project to concentrate on whatever calculations we want to perform on a cluster. But apparently, where is it? User. Apparently I tried, okay, let me check out. Okay, so what's happening is, yeah, so that was that code. We were just checking if there is anything in the RX buffers list. We will get one of the buffers. We will subtract it from the list, check if it's a valid message, and then forward it with the next DMA transfer with the next SPI host. But that doesn't work. I get in boot loop. I can't debug that. It basically, I have to power on and off and on the whole cluster. No, there are like so the connection between the programming pins are at the parallel bus lines. There was like this. That's where I didn't notice that basically they're shared. The programming pins. I have like to, if I want to use all the lines on the parallel bus, I need to turn off the debugging peripheral, and only that isn't the SPI isn't affected, like the 1-bit SPI. However, hey the Shipu, I was able to. I think that even works. Like I tried manual transfer. There was another issue and I don't know what that was. But basically there is like, I don't know, I wasn't able to figure it out. and I thought that was Sunday, I think Sunday or Saturday, and I thought, well, I'm implementing here like the 1-bit serial transfer. Okay, all right, we have like, we can run it at like 32 megabits almost, or what did we try, like 16 megabit, which was like working well. But then I thought, all right, I can't debug that without like taking the whole device apart. And yeah, I would need like to either cut traces or whatever, or build, like take another of the PCBs and make one with only one MCU on that. And what actually that would be one solution, because I spent so much time trying to debug it, and I really need to exclude any sources of errors, because now I have so many moving parts that it was basically impossible. So, and then I thought, all right, I need something really quick and easy for today, for the stream, so we will be able to do anything. Hey Basil. So I thought, oh well, I just take I will change things for the next version, of course. I will certainly use more capable MCUs than that. Either RP2040s or 2350s, or FPGAs. FPGAs, I have them here. I have everything here to use FPGAs. We could also use FPGAs right now with bodging them on, because oh shit, stop. Yeah, I have spare boards. The only issue is I need more power connectors, and yeah, I don't have XT60. Yeah, and I can basically bodge anything to that and skip all the MCUs. Just directly to the two buses and be good. Actually, we could do that. Let me find out if... Wait, yeah, pizza trays. You know what? I'm asking myself now if I can populate everything I actually might be able to. I can botch the bus. So the only issue is that I don't think I have enough power connectors. So I need a lot of XT60 connectors here. Oh, I have a few actually. I would need... Oh, we might have enough peaks. Yeah, I need only one, but we have like different power lines here. Alright, I have enough connectors, it seems. I found enough. Let me check. So we have If that, yeah, it's probably quite toxic. I need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and I have I don't have 13. I have 9, however. I need to find 2 more connectors here. Yeah, bodging the big one isn't a good idea. That's true. Okay, let me think. I need certainly I need XT60 connectors. That's for sure. Maybe I will find somewhere some. Two doesn't sound like it's a lot actually. Let me check that. But we can order them XT60. Order them today to arrive. Oh, that will be close. That will be close. Okay, let me try to get them. Yeah, we can't get them. Oh, we can't. It's Tuesday. It's not Wednesday. Let me try to get them today. Yeah, to test, but I want something working for the weekend, and if I have for the Maker Faire. So if I have something that is capable, I will completely want to populate that. Of course, I can get the Maker Faire XT60 connectors. Standort Germany. There's no such thing. 1 bis 2 Tage Lieferung. Okay, let's see. Ausführung. Oh, that's the high power. Konrad. I don't want this one. These are... It's not. These are brick and mortar. Electronics shops. What is brick and mortar? Okay, you know what? Yeah, we have, but they have basically nothing. You can't get, like, Konrad is one, and there are like few electronics shops, but really I don't know of any that that are still there. Yeah, my Yeah, I know. Okay. And this looks good. You know what? Five pair of those. I will just get them and be good. Okay. Uh, and done. Okay, which is my? This is my. I think this is my business card. Our brick and mortar. Okay. All right. I hope it arrives. In the next days. All right. So we have enough PCI Express ports for sure. I know that. What we could use is this board. If we skip level 3 completely, I didn't show you what else I did. Okay, we are still recapping before we start like the full stream, because I'm really depressed about the progress, because every time I start something, DMA ping pong now, not really. So I have the issue that I couldn't debug level 3 and it was breaking whenever I passed the buffer to the next SPI to send it upstream. And there everything stopped working. And then I thought, all right, I don't have time to waste with that. I thought it will be a quick thing to make an easy 1-bit, super fast 1-bit SPI communication done, but it's not that easy, especially not with, I don't know if it's the WCH chips that are too clunky with those peripherals. It was certainly like ESPs have work easier in that thing, or I don't know, PIOs with RP2040s probably would be easier as well. Anyways, don't have time to waste with that. So I thought, okay, let's make it simpler. If we have, with the interrupts and everything, if we have crashes, less AI. AI is my savior because I can I would read like data sheets for forever. So everything is working fine. It also helped me figuring out problem with my DMA yeah, it really takes time. I'm trying to rush things and that was great. What's the problem? Okay, the configuration of the... I wouldn't say it's the problem with the chips, but if you look at just at the initialization of the SPI peripheral, everything you have to do there is really complicated. So we have, this is not what I wanted. Let me do SPI client. Okay, so basically to initialize DMA SPIs, look at the code that we need. Okay, that's pins, but like the SPI configuration, all right, I mean that's just flags and configuration and everything, but then also the DMAs, then we have like we don't get from the SPI, we don't get, even though it handles chip select, in hardware. So we have, where is it? Let me check that. Oh yeah, NSS hard. So it's handling chip select in hardware. We don't get any interrupt for that or any control. So what I have to do is, okay, I have to set up the DMAs manually for transmit and receive. And then I do like an external line interrupt for the CS on top of that. And then I have to juggle. Also, like that was one issue. I think the priority of the DMA was too low, and I had to make the priority, like whenever I had the issue that the chip select went down, then we had the transmit, and then chip select got up, but the interrupt for the chip select up was triggered first because it had a higher priority than the end of the DMA transfer. So we had an incomplete DMA, whatever handling, when I entered the interrupt that actually wrapped up I just like with the what I did before is whenever chip select is pulled down, I can't change that. This is like in this stupid studio. This like okay, this is debugging. Okay, I don't need to debug anymore. But so I try to handle everything in the chip select. Oh, yeah, this is. I think it automatically changes size. Long fine. So I try to handle everything in the interrupt of the chip select because you never know if you receive only half a message or whatever issues there can be. You never like probably not always get like a full buffer that you set up with your DMA. In that case, you need like to reset everything and wrap everything up. And this is what's happening here. This is like a falling edge that's before the transmission starts, and this is the rising edge which wraps up the whole transmission. And this is also where I disable DMA and so on. And I had the issue that basically this flag is set in the DMA complete, transmission complete interrupt, and it wasn't set before because the priorities were wrong. Now I have like just this break. Whenever I'm debugging, I know something's up there. Anyways, this was working fine, but then yeah, so it's quite complicated to set everything up. I don't know if it's me, I get too spoiled or too used to, I don't know, stuff that's done. But look at that. It's like how many lines of code to set it up? It's 100 lines of code to set up, and there is a lot of opportunity to mess up things. And yeah, I'm working at the lowest level, and that's what I. Oh, okay. What does it say? Give me a conclusion, a short abstract, please. Yeah, raw registers. So I trust. Okay, let me. All in shambles. 100 lines. What? Okay, interesting. All right. Never mind. I thought, okay, if I have like a black box peripheral, and now I have like, whenever I use the peripheral, I have like stuff crushing, boot loop, whatever. I still didn't use my parallel bus, and that was the thing that I thought. All right, if I've I can send a byte in parallel that's 8 times faster. I can even do that manually. Just clock it out, like bit banging, might be still fast enough. And this is what happens here. Look at it without peripheral. This is just definitions of the pins, ports, whatever. This is where the whole code. This is for my helper functions for chip select. This is the initialization. You're screwed. So we have like 20 lines of code to initialize the pin direction, and then we have the whole transmission is happening in like 10 lines of code. This was this implementation that I got from AI. Oh yeah, don't use like for loop, use like pointers, blah blah blah. It's half as fast as this one, which I just rewrote, and it has to be faster, and this is capable of sending a packet of 8 bytes in 1 microsecond. We can take a look at the scope, because then you will see what I mean. It's functional. However, on the other side, I need to receive that as well. And that's the issue right now. Yeah, that would be... Yeah, it's weird, but actually they're almost the same, but it's actually not. It's so weird that like it's half as many we can take a look. I will really... Okay, here is yeah, that's what I think. I don't fully support like how IDF is handled, because they break compatibility with like every version, and every time like you have to maintain like your version of IDF for your code to be working, which is terrible. But it's just a 2-line code, like make a nice API or SDK where you transmit SPI, octal SPI at this speed, blah, whatever, and then it's done. You don't have to care, or you have a GPIO matrix. That would be nice. All right, so let me check that. That's basically the... Okay, you can see the measurement of like we can shift that. Okay, more or less, but it's basically 950 nanoseconds, and that's 8 bytes in parallel. 8 bytes because that we only checking one line of the 8 lines. It's full duplex because we have, as you can see here. All right. Okay. For the record, I'm recording right now. So that's 950 nanoseconds for 8-byte packet, and it's doing full duplex. So it shifts out our packet and shifts in a packet as well. Yeah, the issue is now 8 bytes. That 8 bytes in 950 nanoseconds. And if you would look at that code, the disassembly, I don't know. Okay, let me show you the disassembly for that. We can break it and not break the code, but let's debug that. I will show you the difference. Okay. Can I break it there? No, not SP bus host. Okay, here. Ah. Play. And start. Nope. Where's my... Come on. Ah! Oh, that's the wrong one. That's the wrong code. Wait. Level 4. This is the one. Okay, pbus host. Now. The issue is, yeah. Oh, come on. Okay, pbus level 4. Am I connected to the right one? Yeah. Ah, yeah, it was the I need to reconnect the USB as well here. Okay. All right. So here you can see this is. Can you see? Let me zoom in. The issue is it's somehow opens that up again every time. Okay, so 4 instructions for shifting out the next byte, 1 instruction for changing the clock flank, and then 2 instructions for reading in, and 1 instruction for clock, and then backing egg. No, I have only another scope with a digital probe. We could use that, but it's not necessary right now. Anyways. Duke, do you have like half duplex, full duplex code? Do you use the tricks with the FIFO that like preloading the FIFO and then stuff like that is shifted out? Because I have like the SPI for the CH570. I have like half duplex. I have it working, but not really like full duplex, fake full duplex hack mode. That's why now I also use only packets of 8 bytes because that's the size of the buffer. Do you have like a link? Wait, I'll make you administrator so you can post a link on GitHub if you like. Here. You are moderator now. So you can post a link if you like. We can check that code. Anyways, so this is now yeah, quite compact. Now let's take a look at the AI code. So sometimes like it tried to optimize for good assembly, but it the autocomplete stuff. Okay, and let's compile that and see what the result is. Oh yeah, we need that. Let's run it. This is open again. Thank you for nothing. All right. Start. You see that? Annoying. Okay, and this is now. Oh, that looks the same. Maybe I didn't have the optimizer on. Oh, okay. Let me change. Okay, let me turn that off and see on the scope. Oh, it's the same. That was optimizer. Okay. So, but there is no need. The thing that we proved is, okay, O2. Apparently I didn't have O2 on during this version, but then I can just remove that because this is easier to read. I mean here. This is easier to read and results in the same performance. So, yeah, I wanted to prove something. Yeah, just give me the link to your repo and then I will check it out. I'm curious. Anyways, the issue is if you have like only a few nanoseconds to react, on the other side, how do you bit bang that data in? And that's the issue that I'm standing in front of again. So what I do is PBus client. I don't know. Okay, this is. I think that one was working. So. Okay, let me move that over here. We never got past this while loop. And that's, but I also had, oh. Okay, let's move that. Maybe oh. Oh, okay. If I can make this work, then we might be good, because then we have the parallel bus. Or we try the CH CH417. It has enough pins for us to botch Basil, elaborate. We are we can check if the clock speed, clock configuration. Yeah, basically, yeah, that's for sure. It's running same clock speed or faster even, because I think that one was overclocked. We have like wait, system, let me check that here. Yeah, 96, but it is times 2 because we have like our crystal is 16 megahertz instead of 8, so it should actually run faster. Okay, PBus client, let's check out if we can receive any transmission here, but usually I never get there, or I had an error, I don't know, maybe issues. Okay, I also want to change the compiler to O2 optimization. Duke, I will check out your code in a second. I just want to make sure we don't forget anything. All right, so I really don't need a disassembly. Okay. No, it's active low. Did I make it wrong here? Client. Oh, that's the SP. Oh, really? Why? No. Why? While it's high, CS port in the R and bit, it blocks here. Why it's high? It should be blocking. Yeah. No. This is for the other side, not. Okay, let me break here. Yeah, sorry. Okay, we never get here. Are we even there yet? Where are we? Okay, it's locked in here. So we never leave this here. Maybe I should turn on the disassembly, because somehow it gets stuck in this loop here. Oh shit. Yeah, this is why. Oh, Rabadaki development. I'm blushing. You can measure, you can compare the pixels if it's more red now. I'm really blushing. This is very embarrassing. I was so frustrated today because that didn't work, that code. Oh no. Yeah, wrong register. Ah, I'm red now. I'm red. Oh no, I should also do not receive DMA client. I should turn that off because there is a way, apparently, Basil might know. The DMA is quite versatile on this chip. So if we can't manually like get the clock timings right, of course we could like try to time it with knobs and whatever, but if we can't get it this way around, we can always set up a DMA that reads from the peripheral, the port, and it's clocked by a timer, and the timer is triggered by the external pin. So the DMA can always transfer from memory to memory, peripheral address, basically any address to memory. And the issue is this is made up by AI, and I'm still, yeah, that I don't know if you used that before. I used it before with the CH03 to generate a VGA signal. But I used also like DMA, and I think it was, I could check how I set up the timer. But what I don't understand is how the DMA is connected to the timer yet, or how the timer is attached to the pin, because I never specify here, or that is that is the actual pin that triggers the timer. So there are, I think I didn't use like the thinking model, it was like the flash model. So this is not proven yet. That was just a desperate try to get something working. Anyways, let's try to compile that without the DMA stuff. You know what I oh yeah, we can share. Oh no, we don't have the share tool here. I can share it during using this thing here. Live share. Yep, but how do you trigger? How do you set up the trigger of the DMA? That's, I don't understand how that works internally. You have like somehow to connect the DMA to a trigger source. If I can use like or if I can specify like a bit somewhere or whatever, or I don't know. Shared. I hope this is, can try that. I hope as it's not editing. We are, but this is a mess. Okay. Oh, it's reading everything to my ear. 3 Is it working? Is it working? Okay, let me... it's not really... Let me try to... Why is it incrementing? Huh? No, it doesn't have. Unfortunately, FSMC isn't supported on 64-bit pin versions. I checked that. The AI also mentioned that, but if you look at the no, where is it? There was like this. Product series description. Yeah, that if I knew that, I would use the bigger version. But you always learn. All right, so FSMC here. That's only used by the VC version. We are the RC version. Hey Kaspar! It's 24 hours earlier. Imagine we had an implementation with FSMC that maps basically. You know what? I found it really interesting because it handles everything and maps the data to your memory. Imagine we could access everything like in the cluster just mapped to the memory. That would be so cool. But oh well, didn't happen for this one. Yeah, I'm confused why our data that we receive is only like an incremental value. Do we get ever in here? Huh? Is that optimized? Oh yeah, it's CS address, okay. I'm wondering if we are just too fast. If we are just too fast, because or we are shifting out crap here. Let me change the speed. Or let me do it here. Yeah, I will add the delay, but let me check first before I unplug up and change everything. That would be my way of testing it as well. How can I save this setup, Windows setup, because that's really annoying every single time. Okay, start. Okay, out, in. Why would it just it's so weird. Why is it receiving only a sequence of are we sending data or out? I Let me check that code. Okay, we will do the following. We'll stop it here. We will switch to the level 4 code. Check the main again. Where are the files now? Switch that off. Okay, here. Main. We are sending. No, Monriver can't do this. I'm just using VS Code in parallel to handle my version control and so on. So basically, this is running in the background. Okay, so you know what? I want. Yeah, it is based, and probably it can't even support plugins, but I'm really not. I really don't want to waste time on that. Okay, get next USB byte. All right, you know what? We will do the following. Oh, really? That's bad. Okay, we have this pattern, and then we have yeah, that's what I mean. It's so complicated to set up. That's wait, get out, validate message, test. Okay, yes, let's leave it like that. Oh, no, 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 no. Ah, shit. Yeah, it's I now with FPGA we would be 10 times finished, especially programming failed. Okay. Okay, back to level 4. We can also add the delays. Oh, let's do 1 microsecond and another microsecond here and another microsecond here and here. This is our debugging code. It should send out a message. Ooh. There is always some issue, huh? Okay. Yeah, that's what's happening here apparently. So I mean we have some commenting. So basically, clock mode 1 config timer 2 external trigger polarity non-inverted whatever. That's the trigger for the timer. Channel 2. So timer 2 is tied to channel 2. The thing is, I don't have a breadboard friendly friendly version of that chip to test that thing, because I would love to test it somehow, like with a signal generator, whatever, or 2 MCUs to see if it's actually working. So that would be externally triggered timer. So I didn't test it yet, but yeah, oh well. Now we are testing this here and see if our... I will also click, where is Duke's link? Duke's link. Terran. Yeah, can... yeah, not sure if I have one. Okay, let's do this first. Where's my... here. Okay. What is the in? Huh? It's again just some crap. Okay, let me do pre-initialize it with 0 because I'm confused if this is like some residue from before. It should be receiving stuff. Why am I receiving crap? Oh, we can also check out the other scope with the digital probe, or maybe at least prove if it's always incrementing like values, or we getting our FF whatever loony. Alright, nope, this is what we receive. Why? Something's off here. Oh yeah, this is, there's no function, but why are we receiving crap? Okay, I have another idea. This is running. We should be able to debug the other side because that code also shifts out. Oh yeah, we have the pins that we are actually not able to use because of the debugging interface, but I hope we still are able to read anything. But let's check out this code. Okay, what did we receive? SDIO? Yeah, that's my issue. Ah, yeah, I remember that one. I was looking into it, but then you need like to implement this whole infrastructure. Required speed 50 megahertz. Nice. Yeah, that's the protocol. What pins? No, that's a lot. All right. Let's fix things. Or let's check out the code, Duke's code now. Duke that arrived in the That's a description of how you did it, or? Okay. DMR begin and end once with your ring bounds. 16-bit, the hardware supplies is RAM base. Half. Here DMA loop enable. Don't you have like just a code that would be easier to read? Alright, 16 SP count, non-zero, starts the transfer master mode, auto starts. And that's master. Okay, that's quite tricky. I don't know what to do. What this is? I just need code if you want to share stuff, because can't wrap my head around those tricks or that specific implementation that is thought of there. All right, so what happens? Because I'm confused right now. We are not seeing. Where's my stupid? The 80, congrats! You're top contributor. Yes, it's a coder problem. That's why coders also think that that code is documentation. Oh, code doesn't run. How do I test? Okay, you know what? I need to test. What was my break method? You know what? I don't need a static here, but what? It showed the assembly? In we don't need anything like that. Or I don't need that. I don't need that. Oh, I might have needed that. Don't need that. SPI class. I need that. Okay. Yeah. Always struggle with the order of those asterisks. Makes me feel dumb every single time. Alright, so validate message. Hey Chris. Why it not show? Why you no show? Come on. It's not showing my... Where's my watch? Why doesn't it show the contents? I need it. Where's my watch? Equals what is equal? Is it opted? No, it's not. Branch not equal. Validate message. Huh? Okay, you know what? Let me stop it. I change the properties again to not optimize anything because it looks like it's skipping everything. I used ball and turbo assembler. And Turbo Pascal. And Quick Basic. Alright. Will you validate now? It can't validate it. Oh, here we go. Wait. Why is this loony? Wait. This is test. Okay, yeah. Something is weird. I'm not able to debug anymore. What is going on here? This stupid disassembly. I don't need you. Okay. 255. What did we get for in? Oh, that's wrong. No, this is wrong. Host, import, shift. It uses the same pins for... It uses the same port out. Huh? Wait. Was it copy paste? Out port shift, yeah, in. Import shift. That's one of the issues. Okay. All right. This is what we received. $216. $35. There are like two pins that are useful as SDI. That's IO and CLK 13 and 14. That's actually 3264. So 30 IO is 32, but why are the other pins missing? And this is not working at all. Okay, I need to probe that to see what's going on there. So we let it run and move over to the camera here and measure the packets. Okay, we have several microseconds now. This is on, off, on, and then we have Looney. So this should be all right. We need the receiving side. That would be, let's check. P bus A8 is 68. Okay. So let's try that. So we can see what's coming back. We can also change that. It's too tight, I can't fit more probes. But what we can do is we can see. Yeah. Huh? Clock is falling. So this is what is sent back. So we have 0, 1, 0, 1, 0, 1, 0, 1. And then it's left high, I believe, yeah. Because that's the last pin. If we change like 2 bits, since we are sending a sequence, the second bit, we lose our clock. read that second pin. Now we have, yeah, that's correct. That's also correct. Okay, so actually, actually we debugging isn't reliable. For some reason, I should be receiving the right message. So it is actually counting up 1, 2, 3, 4, 5, 6, 7. There might be different bits that still are not handled right. I'm wondering if import shift is 8. I will pause it here. Okay, in 0. 32 is 0. Okay, sorry. So 32 is 0. I would expect it to be 32 because we have the debugging pin. Then if I... Next should be 1, 30. No, it's not. It's not, it's all 13. Oh wait, no. Do I add watch? Open window, open view, watch. Where is it? Ah, here. Stupid. Yeah, that works. Okay, we are receiving the right data back. So that's fast enough. Oh no, this is not. It breaks off after here. It's incrementing and then falls apart. No, I'm gone tomorrow to the gymnastics championships in Frankfurt. That's why I can't stream tomorrow, but there will be one on Thursday, I believe. Bit shifting. Not sure, really. Yeah. But I'm contemplating of switching to this device here. Oh, it's in Spain. So what is the trajectory? Okay. Huh? Total eclipse, yep. Where's the... Yeah. Huh? How do I... What is this map? I can't... City. Okay. Reykjavik. Oh, partial eclipse. Oh, it will be quite low, so we can maybe see it. How much coverage? Yeah, but 85%. That's cool. I didn't know that we could actually watch it. I'm wondering, since I'm in Frankfurt, if we can go to on a skyscraper and watch it from there. Hmm, that would be cool. All right. Yeah, Berlin, but not everything is Berlin. 85, it's not bad. That's cool. Yes! The last eclipse. Desert. There is no desert close by. Oh, yeah, we'll have to see it. Why am I so tired? Oh, peeps. Okay, let's wake up. I'm wondering, okay, why is this broken? Blind Looney. At 8 p.m. I will just watch through my clearly missing booster, yeah. Watch it through my phone. And it will be easy. And it's so low, so the UV actually is quite limited. Oh, so why is raw? Okay. To go to close it. AliExpress. I have this thing somewhere. Lupenbrillen. Oh, look at that. Gratis 3-Tage-Lieferung, Donnerstag bis Freitag nach heutigem Zahlungseingang. 25 times. Hey, food editor. Thank you very much. Yeah, it has built-in light, which is quite good because I'm bad at organizing. I don't need like all the other crap though. A 25. I mean, that could actually arrive in time. Let me check Amazon. Open Brille. No, these are shitty. 14 times. 40 times. 15 times. They look all not bad. $23 times. History, yeah, history function on YouTube. Okay. Ah, 14 times. LED Lupenbrille 50-fach. 50, no, there is no 50. 23. This is actually the most it goes. Let's read. Oh, yeah, we can always read. But where's? Oh, you do like two. So what do I want? Oh no, I hope I will live until then. What kind of AI image is that? Where's my stream? Then can find my stream because I can't copy links from here. Let's check him out. I have thing like this somewhere. Let me check. Let me check if I can find it. that shit. I want something freehand. Yeah, okay. It's not really like a comparison that yeah, not this microscope. Okay, let me check if this is any good. Schnellgehverwechsel ist sehr gut. Keine erkennbaren Verzerrungen durch die Kombination von zwei kann man sehr starke Vergrößerung einstellen. Beleuchtung ist gut. Ab einer Vergrößerung von 6 ist aber die Parallaxeverschiebung so groß, dass man nur mit einem Auge arbeiten kann. Gefällt wurde mit einer Box und 3 Verschluss. Okay. Oh, okay. You need to get quite close if you use high magnification. Oof. Yeah. Okay, let's see what is best rated. Sorted by average 4.2, 4.3. Okay. That's not what I want. I want something head mounted. 4.5. That's 82. That's oh, look at that. This one, 30 bucks and 200 ratings and mostly positive. But what magnification is that? Does it have a light here? It has a light. Okay, 3.5 times is not that great. Probably that's why it receives good rating. So what is this magnification here? Yeah, I can. This is like more than 2 times. So basically, I get something like this. That's 2 times magnification. I would need something more than that. 5 times would be great. like multiple lenses. And this is, there's not many options though. Hmm. Yeah, I need it also fast, so probably won't get it fast enough. 3.5, you say. They also don't ship fast enough. I would try the one with what is this? What kind of AI is this? Prime, befristetes Angebot. What is this? 3.5. I guess this is basically the same. Oh, this looks sophisticated. 15 times. Huh? What does that do? 3.8. Yeah, but you will never be able to use both eyes in that case. But actually, you know what? Can I get this until Donnerstag? Yeah, I will just buy this. Okay, I buy this. Don't share my. Yeah, I will just find out. And this will be. This is business expense. And. Tschüss. It's bought. Okay. That was done. Now, shall we try this one? It's last topic for today. I will try to get that glasses. Yeah, that's the thing. I will just send it back if it sucks. I canceled Amazon anyways because they fail to ship in time. Schmuck, not schmuck. Ah, okay. Okay. Duke, that I will copy that. That's more what I'm talking about. measure throughput. Okay, interesting. So, is there a copy? It's downloaded. I copy it in my clipboard. Okay, I will put it in here. Shares offline. Sorry. Okay. Zero cluster. Okay, I'll add this. To my code. I want to test the CH570 if we can, if we replace basically the whole contraption. I mean, I can't code tomorrow, but there is. I have a specific debugger for the CH417, and it's not that one. That's also not that one. Throw it away. I don't know what to do with such a thing. I have so many Linky debuggers. I don't know. I had a specific Linky for the 417, but let me. Oh, again, why? Just opened. Do I have C? Okay, let me try to download the latest. The latest PCB. What is it? 417. H. Oh, so sorry to you. So sorry, Flyken. Here. Okay. Okay, let's check out the examples of the 417. We have oh, that's the oh, we can't have CDC here. CDC isn't specified for that or what? Super speed, okay. So device or host. What do we have? Can we try full speed? I mean, we can start with that. I'm wondering if that will be similar fast. Wait, which one this is? This is a USB 3 connector. Not now. That's a dual core, so you you have like two codes. Core 1 and core 2. Okay. How do I attach it? Nine wires, yeah. Doesn't look like it's 9 wires here. Yeah, it has some. Wait. Switch the camera. So you have T plus T minus, R plus R minus, D plus and D minus. That's that. Okay, I can turn that off and I can turn that off. All right, less fan noise. Let's see which one of these programmers even still works. That has a noise. Okay. Turns on and off. This one is the blue one. It is. Ground. Blah blah blah. Do we have a data sheet for that? Data sheet reference manual, maybe. Data sheet is this. Latest data sheet, okay. Yeah, let's for now. I just want to try full speed USB and then see if it's actually full speed, high speed this time. I mean high speed USB. But now we need the programming pins, which B8 clock, B8 and 9 clock is B8 9 and ground. Okay, programming pins, yay. Now we need USB. USB, let me attach it to USB. Okay. What? Yeah, USB 2, but not USB. Wait a second. You kidding me? OTG, VBUT, or... Yeah, we will find out. I will now check if we can get anything from that. Oh. No. Nope. Can we get the linky? No, we can't get linky. Update linky. Is the linky using the right? Maybe it's... What kind of weirdness is going on there? Okay, let me try a different linky. Not sure if that one... But I know it was the blue one. So... Yeah, this one is not reacting at all. No, this linky is dead. Okay, this is certainly dead. one wire. Yeah, that's the worst. I have like my linkies are on off working whenever they like, it feels. Succeeded to set one wire serial debug mode. Begin to set chip type failed. Chip type is not matched. Okay, so is it really like the USB port, or what is the issue now? Maybe it's because I connected, but this will be terrible. Ground, let me check. Power. This should be power. What? Link utility. Is it? I don't know. What is the latest one? Where do I get it? I need to look for that. I'm riddled now. Okay, let me supply the power from the linky, but I'm not really... VBus USB. I know I had this. I had it working with the specific blue linky that I got from Patrick. I think it was this one. I need to be sure. Chip, failed chip type, link. No, I can't connect to the linky. Heh. Okay, I will try to get a better link utility. Okay, version 3. Okay, here we go. Latest link utility. Failed. Connected risk remote. Hey, holy. Know what? Is this a Zedic problem again? Blinky is blinking for whatever reason. Uh, um, yeah. Check. I have no clue. Where is it listed? Ah, we are desperately trying anything. Pivoting towards this device, if I ever can program that. I had this programmed before. Wondering why this is now in the weird blinking mode. Okay, I can't see that. Failed. This linky refuses to be updated. Bricked it. Okay, I will do the following. I will plug it in and then instantly click. No. This one is bricked. You know what? These pin headers, I started to notice wait a second. Let me start my old link utility. Maybe because it was running in the background. Okay. Get both link utilities on. Chip is wrong. Well, this is one wire interface. I don't want one wire interface. I want two wire interface. Okay, that one is updating again with the 2.6 version. Two wires. Huh? Can't even get the link, you know, connected. No, ESPs aren't out of options. Actually, if everything breaks, that will be my... This one refuses completely. Yeah. Again, failed. Chip type not matched. Chip. Okay. Let me now. Oh, good night, my Basil. WCH. Ah, why so difficult? Okay, I will try. These linkies didn't work. I will try one of those that I know are working. Maybe the wires are terrible. No, I don't want to update it. No, not doing that. I rather go with this version. Nope. Okay, I don't want to risk my linky here. Do you have another one? Nope. I know it was one of the blue ones. Alright, these are updated. Okay, this one wants to update. But it won't update. Now it's bricked or what? No, it doesn't. It doesn't update. This link utility tree doesn't work. It's buggy. I don't know, or it doesn't work with the other ones. No, I don't have any other running. One utility at once. Okay, this one works now with 2.6, but I can't connect with the device. So how do I? Is it actually? Is it actually such that still in one way? Yeah, but okay, let's try again. PB8 is clock, is it? PB8. Not that I try different wires here. And reset as well. Do we have reset? No, we don't have reset. Okay, these feel a little bit better. Like they actually making contact. Yeah, one wire interface. I don't mind using. Let me unlock the chip. Chip type is wrong. Let me supply 3.3 volts and do an erase. Who knows? If it's fade chip, okay. Oh. Ah, you see that? We got it. Ah, we power flashed the whole thing. And now it should be alright. Okay. Ah, tools. You know what? I just. Okay. Let's plug it in and see if we got anything. Okay. There it is. I need my tools. Now the microcontroller is already programmed. The only thing that we have uploaded the full speed. I hope 3F 5F. This is slave and this is master. It's interesting where the implementation of the CDC is. Okay. Here. Yeah, that's slow. Where's this? Is this full speed USB? What is that? Oh, interesting. It actually simulates like the transmission with the bits per second. Oh, interesting. It doesn't ignore that. Okay, so let's change the code. No, we need like I will start with that, but Yeah, 4.5 megabits is the highest it does. It's probably the implementation. I'm wondering if we can change the implementation here. Yeah, we were fast already. Um, okay, let me check. Was this... Is this... Where's the implementation? Hardware. We have two mains. Okay, the fast one isn't using the peripheral. It's the smaller core. ADSL. Oh, we are using this before. We can send this over clock line. Oh, it's full speed, not high speed. I loaded the wrong code. Okay, let me check again. Or it's, but I don't think so. USB high speed device. What do we have? Human interface. But if the hardware is implemented on the slow core, high-speed device, okay. It was 3F. Okay, now how do I connect it though? Because I need the forbidden cable, USB A, USB. How do I do this? I have some adapters though. No, these are from USB A to USB C. I need the other version. Ah, but where is it? My chaos here. I had it recently. How do I get what? Oh, assistant? I don't know. I turned it off somewhere. I clicked on it, disabled it somewhere. I don't know. Can't remember really. Sorry. Where is my USB? I have so many adapters. Ah, give me a break. Ah. I also had a cable that was having that adapter built in. Can't find it. How do I? A to C. Yeah, A to C. Huh? But I don't have USB-C at my PC, unfortunately. That's the issue. I have only USB-A ports on my old school. Wait a second. I had this adapter for. No, that was also USB-C. Phew. Oh, here it is. I'm using it for the cluster. Okay. So I will be able to use it also for that, I hope. Okay, let's see. Okay, that was the slow speed. Five megabits per second. That's the configuration stuff. endpoint download tx buffer. Okay, let me give that whole thing failed to erase. Oh yeah, they're sharing the. Oh no. Okay, so actually they are sharing the pins with the high-speed USB. So debugging in high-speed USB, again, an issue. Ah! Damn it. Okay, let's try. Oh, it's not showing up. UART. I mess it up. No. Okay. I don't believe it was this issue. This is just UART communication. No. Oh, it erased everything. Wait a second. USB device. Okay. Mm-hmm. RxDMA. We don't change that. Data in stage processing. Okay. Let's see if. It is one of these here, endpoint 2. That was the implementation as far as I remember. I can compare it though with our implementation here. Endpoint 2. Okay, so this is what's happening, what's supposed to happen whenever we get that token. We're missing ACK or something. Yeah, let me just... Is it even that endpoint token out? Not that I changed something that's not supposed to be changed. Config. Okay, they do the config first. Okay. Yeah, I guess we will do it completely. Replace it with our code here. I don't know if I need to really erase both. Oh, that merges that merge bin. Okay. Yeah, that's the same 22 megabits that we saw on the other device. Okay, we won't get any faster with that implementation, but I guess we would need like to make that tighter. And the timings specifically. Oh, I played with the... Oh, you know what? How about we change size, we change optimization settings and try again. I don't think it compiled both. Need to get used to it, how that looks like. Okay, let's see. Let's test now with optimization. Here. Now same. Doesn't change anything. Alright, that's it. Okay. Now no, we are using high speed. That was the high speed test. Because there is no CDC implementation for super speed. But there is something else that might be interesting. I'm wondering how hard it would be. Okay, we can ask AI. No, 480 megabits is the maximum on full speed. I'm also wondering why they are using the slow core for that. Maybe the bigger core would handle it better, but I don't know which one has the access to all the peripherals. If both or only the smaller one. Okay. Mandate. Ah, gross. Ah, meh, meh. That sounds like a lot of work. But there are not many super speed examples. If we have we have like what is this 372 device? That's like a bus or that was ludicrous speed as well. Okay, so hardware. Okay, where is the hardware implemented? Okay, it disables debug interface. Super speed device initialize. Host. Yeah, but the host, the the dev port is the USB host, and I won't be able to connect it to my PC. I need something. This one uses like a camera interface. But we don't have the camera installed, so warm reset, super speed, okay. I'm wondering if there is, this is super speed device in it, if there is a generic, if it's generic implementation here, and then how does that work? Set device address. It looks very generic, like the functions are quite small. Link state. Okay, that's the hardware. Super speed device in it. And then, are we doing anything on the other core? That's the hardware. Oh, 3F and 5F. And if we are let me check that. An ID. What is that? Oh, example routine to emulate a USB custom device. This routine demonstrates super speed to emulate custom device with endpoints, down endpoints respectively, endpoints, upload, download separately. The device can be operated using bus hunt or computer software. This routine needs to be demonstrated in conjunction with the host software. If the USB is set to high speed, okay, let me download that. The issue is it disables the programmer. Okay, need to download that. Trying the 417 chip. Oh yeah, doesn't do anything. I can't hear it. Huh? Okay. Good night, Ushipu. Let's see if how it's unbekanntes Gerät. Okay, super speed doesn't work. Okay. So best bet is that, or what else we can use is no, ESPs don't have USB super speed. This person okay, okay, user blocked. I don't know what kind of problem this person have. All right, we have we still have what is going on? Ay. And my on screen chat doesn't let me just remove that on screen chat for a while before we scroll away. You need to write stuff. Didn't filter that. Thank you. Sonic. Spammers, but why? Why? I mean, probably kids, huh? I'm still visible. Here we go. ITT. Okay, we have an Ethernet port on this device. Maybe that one is better, but where's how is Etherport used here? The USBs is weird, or we don't have a super speed example. Okay. Super speed. Let's check GitHub. No, there is nothing. Yeah, that's the regular one. There is no new stuff. The generic device, though, we could try that. Okay, I don't give up on super speed. If we can do this device, it will be difficult to access it. Okay. Unbekanntes Gerät. Doesn't work. Okay. I give up on that idea, but we have the Ethernet port. Where can I find the Ethernet port here? In the Q, OPA, Flash, FS, DVP, DMA. Yeah, I should ask the CH32 Fun community. They might have, you know. Yeah, I have both. But it's this weird adapter in between, so. RJ, yeah, but what is, where do I find this? Here in this abbreviations. Ethernet, yeah, there, you're right. DNS, raw, Mac raw. MQTT, what? UDP server. That if we can if we can okay, I don't know if there was there a WebSocket. This disabled my. Okay, I need to use the reset. Okay. All right. I don't need that then. I just need power. How do I provide? Let me see what it says. I have no clue. Let's connect it to my switch and see what happens. I just need an Ethernet cable. By 3? Do you think it will brick everything, destroy my... I need a short cable because I have the long ones here. Alright, I will use the long Ethernet cable. Ah! Let's see what happens. There are certainly some LEDs. Yeah, I think also the router. Okay. Let's see. No, you're kidding me. No drop frames. Okay. Oh yeah, too high compression rate or something. Oh, maybe I shouldn't share my... Oh, did I share my MAC addresses? Please don't do whatever. Why do I see... probably... Damn it. What? How do I see which one? When I disconnect it? How do I see on a stupid Fritz box? How do I see my devices here? Without sharing my MAC addresses. Netzwerkverbindung, bridge, smart fridge, Oppo, 1 gigabit, probably not. PC, that's also not that. 100 megabits. Don't think it works. It blinks, but I don't see. How do I use that? maybe I can debug it. Aha! Netlib driver, Ethernet driver 100 meg. Oh, okay. It says, ow! What is TL? It must be. Okay, I will try the Mac detect Mac decode. That's TP link, yeah. That's TP link. No, it's not listed here. Uh, 10, what? Oh, it's not in the, okay. Let's try. Yeah, it doesn't open. Okay, maybe try the DHCP example. Please start that. That's where the example is shared. Web server. DHCP there. Oh, come on, yeah, okay. Okay, you know what? Okay, common HTTP. Let's change the IP address then. Admin 123. Oh, that's the HTML. Cool. Where did you see the IP address line? Okay. Oh, there. Yeah, okay. And our is our weird network is 178.8, and then let's do 178, and let's give it a weird 233 address instead. Oh, mode. What is this TCP client? This is the configuration is also E100. That's so weird. Okay. Yeah, that will probably not work, my friends. What? What? How do I test speed of this website? Port settings, basic settings. Okay, basic settings. That looks very fast. This. But not 100. 100 would work. I think 100 is. Let's do. I would like to know what speed. Test speed of a specific local. What do you mean modes? Oh. Server. Send a file. You know what? Yeah, it isn't fast. 25. Hmm. .7 kilobytes in 27 milliseconds is the lowest here. 3.3 kilobytes in 13 milliseconds. Yeah, that's not much. Main HTML. Yeah, how do I how to simulate a big file there? Web server works, that's good. I like it, Picasso. So they're using, oh, it's so late already. Ethernet driver. Yeah, but I mean, how much of that arrives at the end? That's okay. Let me check. Where are the GIF files stored? That's the binary files. Okay, HTML logo. It's the binary. Copy flash page bang. Huh. What is this? HTML buffer. Five kilobytes. Yeah. I'm wondering how it does. I mean, if you have bigger files, they won't fit into the buffer. Where is the buffer used? Okay, I'm too tired for investigating that. But I would really love to see. I mean, if we can Oops, what did I do? Come on, net config. Okay. So just using more memory. Net config. Let me check this header. Oh, shoot, I need to get up in 5 hours. I really should go now. Otherwise I will be too tired tomorrow during the championship. Okay, file link. Main task. Ethernet init LED configuration. Get MAC address. Ethernet configuration. It's interesting. We have to look into that. What else? Also an option would be using an ESP32 instead for full speed USB. If we can make that, or Wi-Fi, can that make that work? Anyways, I hope I can stream on Thursday, but I really need to pack up everything on Friday morning to go to the Maker Faire, and I hope I can bring this device with me. Anyways, I see you next time, hope still this week, with good news. Bye bye everyone. Bye.